So let's have a look at recursion. Again, let's compile. I'm going to leave one main class. All right, now I'm going to create a new dialog in order to split or distinguish between the topics. And I want to run this in online compiler. So I expect chat to provide what packages should I include, and obviously this main program, maybe this could be small letter, I don't know, void. All right, so class is main. Now it works well. So let's try other values. And let's try to understand what each line does. So obviously this one is assigned by programmer. Result as well. Here obj is what we name, and the calculate factorial is a built-in function which is applied to this, the obj. And then the calculation itself runs over here. But what I think is that we should have have a cycle, because otherwise it is too simple to be true. Here you need to use recursion to solve this task. All right, so obviously okay, now we have the explanation. Because calling only one function doesn't show that we use the recursion. Okay, so we're creating an object and we use directly calculate factorial. Okay. Declares an integer. Yes, of course. Now, calls the method and passes number. Okay. And presents the results. And recursive call is n. Okay, so the only recursion is on line 16. So if we would use a loop, we could see the number of iterations. How could I count the number of iterations or print provisional results? Alright, so imagine we would use something like this. What would happen? Yeah, so recursion went too far, and then we can tell both are integers. Okay. Uh, okay, so we are calling the same function over and over again until we will reach number one. System out, print line, and maybe just n. Okay, would it print anything? Yes, so then it is already kind of looping, so I'm calling the same function, and let's make it 13. And then I see that it starts at 13 and then goes until 1, and when it's 1, it returns just 1. Yes. And if I input negative number, I get an error. It's 0. Very good. If I enter something else, error. Very good indeed. All right, so with recursion, we can call the same function over and over again. And here, for example, we could modify how many cycles we do. Say, we can rename it like this, and we just do it like this. That way we adding up. Yes. adding up all the values, and we also could calculate the sum of squares. So these are values of n as indices, and so on. Imagine we would exclude this line. What would happen? Nothing unless we enter 0. Or, sorry, minus 10, for example. Yes, so, and it's still running. Execution halted. Okay, so it runs too far. And if it is just 1, it will return 1. If we exclude 1 from the main cycle, what will happen? And if it is 0 or if it is 1, then still we get the correct result unless we take in 0 and then we break everything that we get 0, which is wrong. And if we get minus 10, then we get 0. Yes. Very good indeed. So if we call the same thing twice, and we start with 4, just yes, so don't print this output. Stack Overflow, correct. Okay, so now we get some result without Stack Overflow, and for negative values as well, minus 14. So it will go too far away. Okay. Yes, so it's just minus 1. Okay. Euclidean algorithm. And with letters. These are examples we're going to see next time.